This section contains two matrix match the column types questions. Entries given in column 1 have to be matched with entries given in column 2. And for entries in column 1, there may be one or more than one entries in column 2. So let's start with question number 36. So column 1 contains the reactant and stereochemistry of the product mixture, while column 2 contains the reagent for that conversion. Match the entries given in column 1 with that in column 2. So let us first talk about the entries given in column 2. So in column 2, we have been given a set of reagents. So the examiner seems to be interested in the stereochemistry of the product as we change the stereochemistry of the reactant. So if we look at the entries in column 2, there are two sets of reagents, one which cause syn addition and one which cause anti-addition. If you look at the species which cause syn addition, we're going to have option P, we're going to have option Q, and we're going to also have option D. Whereas if you look at options R and S, they cause the anti-addition. So now we know that when we have a trans alkene and when it is allowed to undergo anti-addition, we get a meso compound. And if we have a cis alkene, it is allowed to undergo anti-addition, we have a racemic mixture. And we'll also have the other two corresponding cases. So let us first look at option A. So we have a trans alkene which is forming a meso compound. So obviously we'll have to have reagents which cause anti-addition. So we have R and S as the correct matching for option A. If you look at option B now, we have a cis alkene giving us a racemic mixture. So obviously we have to have reagents which cause anti-addition here. So the correct matching for option B will also be R and S, which is the anti-addition set. Now if you look at the C statement now, which converts a trans alkene into a racemic mixture. So it has to have syn addition. And the reagents which cause syn addition among the given reagents are P, Q and T. So we have to select P, Q and T for this option. And if you look at the last option now, option D, which converts a cis alkene into a meso compound. So there has to be reagents which again cause syn addition in this case. And like the previous case, we're going to have the matching with P, Q and T. So students, this is the correct matching for question number 36. Let us look at the next matrix match the column. So we have been given the Ka and Kb values of acetic acid and ammonium hydroxide. And the examiner seems to be mixing a set of acids and bases in different proportions and seems to be interested in the pH as well as the variation of the pH with different changes in the system. So if we look at the first option now, so we have 1 liter of 1 molar CH3COH and we have 1 liter of 1 molar CH3CONA. So we have a buffer solution in which the concentration of the salt and the acid is equal. So we are going to have the pH of the system as equal to pKa. So for the A option, we have a buffer in which the pH is equal to pKa, which comes out to be equal to 5. So if you look at the entries given in column 2, pH of the solution is less than 7. This will be a match for option A. So it will be matched with P. So Q will not be a match. If we talk about the option R will be matched to every single entry in column 1 as on addition of H plus, there will be a decrease in pH. So R will be matched here as well. So we can probably note that R will be matched with all of them. We need not check for the other options. If you look at option S now, on dilution pH increase, we know that the solution is a buffer solution and the pH of a buffer is not affected upon dilution. So S will not be a match and T will be a match as the solution acts as a buffer. So for option A, we have to match P, R and T. If you look at option B now, so in option B, we have been given 1 liter of CH3COH, which is 1 molar, which is added to 1 liter of 1 molar NaOH. So there will be complete neutralization in the system and we are going to have the formation of CH3CONA. Now this CH3CONA will indulge in hydrolysis and it will react with H2O to give us CH3COH and OH minus. So which will make the solution as basic. So for the basic solution, we have the pH more than 7. So Q will be a match in this case. And if we talk about R has to be matched with every single option. If we talk about the S option now, on dilution, the pH increases. On diluting the system, the OH minus ion concentration will also decrease. So if the OH minus ion concentration decreases, then the pH of the solution shall also decrease and not increase as mentioned in the option. So S will not be a match and T will also not be a match. So the correct matching for option B is Q and R. If you look at the C option now, so in C option we have 1 liter of 1 molar CH3COH and 2 liter of 1 molar NaOH. So this is going to generate a system where there is CH3CONA present and also there is NaOH present. So both will be present in equal amounts. So now if we talk about these two species, both of them are bases, but the NaOH is a very strong base as compared to CH3CO-. So the activity of CH3CO- shall be suppressed in the presence of NaOH. So the solution shall be basic. So the pH will be more than 7. So Q shall be a match. If we talk about R has to be matched with every option. Now if we talk about S, that on dilution the pH increases. So we have OH- ions in the system, and if we increase the volume, the concentration of OH- shall decrease, which means that the pOH shall increase, which will follow that the pH shall decrease. So S will not be matched with option C as well. This system does not act as a buffer. So the correct matching for option C is also going to be Q and R like the previous option. Now if we talk about the last option, which is option D, we have equimolar amounts of CH3COH and NH4OH. So complete utilization will take place and will have the formation of ammonium acetate, CH3CONH4. So this is a salt of a weak acid and a weak base, and the pH can be written as half pKw plus pKa minus pKb. This formula contains no assumptions, so it can be universally applied without any hesitation. So the pK and the pKb values have been given to us. Both of them are equal to 5. So the pH shall be equal to 7. So the solution produced by the mixing of solutions mentioned in option D shall be neutral and the pH shall be equal to 7. So options P and Q will not be a match. Option R has to be matched with everything. If you look at option S now, that on dilution pH increases. On dilution, the pH will not change in this case as it was neutral before and it will be neutral afterwards also. If you look at the T option has to be matched with this. So the correct matching for option D is R and T, and we have the correct matching for the whole matrix.